This is a demonstration of strategies for solving objects in Equalizer LSF. So right here we've got an eyeball and we've got 2 track points. Now if you've got 2 track points, that means that you can do 3 degrees of freedom. You can do pan, tilt, and roll. But if you only had 1 point, then you'd have to turn one of these off because it would not be able to solve more than just X rotation and Y rotation if you only had a single point. So we'll use the solver, and then of course the translations are going to be locked off, and that's because it makes no sense for an eyeball to translate. It only makes sense for it to rotate, especially since the pivot point is correctly inside the eyeball. So we'll do an LSF solve. We hit calc. Notice there's always going to be a slight error. Use result, and it looks really nice. Now if we only have 1 point, let's say we disable this by let's say making it a lineup point. So then we're going to have to choose which one of these to use. So let's say we just calculate. We're going to go to static value and we'll pick up the current value there. Now we hit calculate. We've got a 1 point solve, and the error of course will be 0 because mathematically you can always get a single point to line up to itself. Now if we hit use result, it's going to look a little weird. It's rolling around crazily, and the reason it's doing that is because there's a gimbal lock with the camera and the whole system. So the way to get around that is, let's go here to zero out camera rotation, and we choose the camera group, get here, and what it's going to do if we look at this carefully is that we intentionally set up that the camera is pointing straight down, so it's gimbal locked. So what this tool is going to do is we hit zero out camera rotation, and it's going to take the whole operation of the camera and the object, and it's going to level it out. So it's still going to have camera rotations, but everything, we're going to be away from the gimbal lock zone of death, which is minus 90 or positive 90. So right here, if we go with the solver, again we have to be sure to choose the object, because the LF solver is modal, so it knows whether it's got a camera or an object. And so we can get current value again, and then we can calculate. So now it looks correct because we're not gimbal locked. Now again, it's not quite right because we're not doing any rotation, and a real eyeball, a real eyeball is going to mainly have pan and tilt. It's going to have RX and RY, but it's probably kind of a little bit of RZ also. Okay, so now to get this completely, so now if we want to get that to work, of course we have to do a 3 point solve. We have to do 3 channel solve, so we can put this back on, exactly surveyed. So now if we look at the solver, it's set here to not use survey free points and not to use lineup points, but you can change these as you like. So here we calculate, and we've got a slight error, and so now it's working very nicely for all 3 degrees of freedom. Now if we want to get this back to where it was before, where it's looking down, we just restore the camera rotations. Now the camera's looking down, and the solve's still working. Now on this shot, it really has to have a pivot point inside the eyeball, and it has to be rotations for the solver. Now we could do something dopey, like take the pivot point of this and move it to the top. So let's go to make object path. So what it's going to do is we'll pick one of these points here, and then we'll make the pivot to that point. So now it's on the surface, but here, since that's where the points are as well, Mathematically and from geometry, it makes no sense to rotate it because the solver will just go crazy. So what we could do, especially again if we do the zero out, is now we can do translates. Again, we've got the wrong group here. So now we'll lock these to static values. So instead of doing rotations, we can do translations. Let's calculate it. Again, it doesn't make much sense what we're doing, but let's see how it looks. So here, the eyeball is translating to lock our points. And then again, if we take one of these points here and disable it, we'll disable it just by making a light up point. That's as good a way as any, sort of convenient. So then, because it's looking down Z, then we can just go to lock the static value, and so now we calculate just for X and Y translations. And notice it's actually giving an error because even that doesn't quite make sense. So now we've got a translation here. And then if we want to get it back to looking down, we can hit the restore camera rotations. So this zero out camera rotations has two different purposes. One is to avoid gimbal lock for rotations, and the other is if you've got translations that are looking down Z, everything's good for the camera. But if the camera were at a 45-degree angle, that would mean that if you animate the translations in world space for your object, the TX and the TZ will crosstalk a little bit because it's at an angle. So let's just restore that. So for almost any sort of object track, even if you're just doing the regular equalizer solver, it can be much easier if you just use the zero out tool. So you avoid gimbal lock and crosstalk issues. And the gimbal lock and the crosstalk are actually two separate related but separate issues. Okay, so now it's restored and the translation's still working. Again, with this only sort of makes sense if we move the translation to the pivot point here. So if you're doing rotations, the pivot point should be here. If not, it's mathematically, you'll see it's quite screwed up. If you're doing translations, it would be here. Again, this is just a matter of a pivot point issue.